Today we're learning about making maps, essentially geographic visualizations. Geographic viz essentially is maps. We basically know how to read it. We use it on a daily basis. I don't think there's anyone that doesn't use maps at all. It's just like one of the most popular and just ubiquitous visualizations that we use. So this is a map. It has a lot of information in it. Can you type in chat anything that you can read from this map? Just let me know. Okay. Okay. So you all seen it, Chicago. Someone saw Costco. You're seeing rivers, museum, Costco. Where's Costco? I don't see it.
Above National Museum of Mexican Art.
National Museum. Oh, okay. Costco wholesale. Okay. Okay. Great. Heart of Chicago. Yeah, people who love Costco immediately see it. Great. You're seeing a lot of different things. Some of you saw areas, some of you saw like these highways. Maps are good at showing us a lot of information about cities and about places that we go to, locations, etc., etc. So essentially, it's a truism. It's because I think it's just you all know it, but map is a series of data that has a spatial sort of location qualities. So we can place them. Anything that we can locate, it can be on a map, right? On a geographic map. Map is in computer science is a more broad concept, but today what we're talking about maps is basically putting things that have locations where they are on Earth. Okay, so I want to start by taking a few minutes, maybe 3 to 4 minutes, and just take whatever tool you have, a Microsoft Paint or just a pen and paper, and draw a map of Vancouver Metro that the way you remember it. Please don't open like Google Maps, and I just want your memory of Vancouver. The more crude, the more weird it is, the better. Anything that you remember. The form doesn't matter. I want to see your mental representation of Vancouver. I've created a thread on Discord. You should see it in general chat. And please paste them. Again, doesn't matter if it's like accurate. I just want to see what you all remember. I'm going to do it too. All right. I drew mine. Okay, let's take 2 more minutes. I love the level of fidelity that the first two people have. That's exactly what we're looking at. Okay. Keep them coming. I'm going to start with. Do you all see the image?
Yes, we do.
Okay. So we're seeing. Is this a bus number 3 or something? Then we see Gastown, Stanley Park. This is downtown. R5 to downtown. Beautiful. There we go. So you have sort of some regions drawn, some locations, some bays. Beautiful. Okay, so this is. I'm gonna keep them coming. So let's see. Okay, we have Vancouver, Burnaby, Surrey. We have North Van, New West. Great. So we have some regions. We have these edges. Let's look at a few more. We have basically routes. Costco. Some routes to different locations. Oh, all the Costco's.
Yeah,
Wow, this is a map to Costco. I
it's a
love
broken
this.
student's map.
Yes. Okay, let's see. Let's see what we have. What else do we have? Stanley Park, Richmond, Vancouver, Burnaby Mountain, Coquitlam. Okay, love it. Love it. Love it. Let's see some. We have some unique maps. Okay, a bunch of regions. There's Surrey, there's Richmond, Delta, Burnaby, Vancouver, North Vancouver, and Calgary. Basically, a graph. There's if all the different regions just linked to each other. This is a really interesting representation. You want to see mine?
Nice.
Pretty good, no? I have UBC, Kitsilano, my house, Main Street, and then the train, Seattle, and then downtown, North Vancouver, and West Vancouver. What is chat saying? Yeah,
We're
study,
talking.
eat, sleep cycle. Yes, exactly. Our lives are basically, mine is basically the same because I've highlighted the places I eat and my transit and where all the Iranians are at, and then just some places that I know. Okay, I'm gonna do a couple more interesting ones. There's one that says, this is the part that you don't know. I love it. This is, oh, clubs. So you're highlighting some regions and some edges. This is a really interesting exercise. Everyone, and I'm going to show you why we're doing this. Someone's just drawing the train, the expo line, but they're also drawing the edges of the city. Is that you with the expo line? Yeah. Which one is you? Oh, this one?
Oh,
This is
nice.
crazy. This is basically the map. Okay, cool. This is the map of Vancouver and all the train stops, but then there's also some neighborhoods as well, like where the neighborhoods are at. Your image of Vancouver is shaped by these places. Okay, let's see the last one. These are super creative. Someone just drew the regions: downtown, Richmond, Metro, and Surrey. 3 trains plus buses. I wish I could find it. Wow, this one looks pretty. Wow, this is pretty accurate. Wow. Is that you? Nice. Okay. Yeah, this is beautiful. This is an actual map of the city. Nice. Good memory. Okay. Good. Love these. Let's get back to our what we're learning. Okay. Now let's see how other people conceptualized Vancouver. This is one of my favorite things in the world. This is called Hood Map. And this is basically people crowdsource what they think different areas in Vancouver are. This is amazing to me. You can basically see how people view the city. See, lots of Persians. That's the way. Yeah, it's crazy. It's richer than God, the super rich. And then here, not all of them are nice things, but hipsters. This is where I vinyl record district, dogs and pot, moderately rich people, chicken smell. These are some of the things that I don't know about. Yeah, Lululemon. Yes. You guys should go check it out. Like my favorite was actually Chicago because I learned about this from Chicago. It's amazing. This is so accurate. Billionaires, like like this is so accurate. It's called hoodmap.com. And you zoom in and you get more detailed. It's so correct. Everything is just correct about Chicago. Anyways, I love this. It's a different way of representing how people remember things. But the way we did it is essentially the way Kevin Lynch did it. Before we get to that, I'll show you what Kevin Lynch talked about. Essentially, there is space where we walk around and move around. It's something physical, right? It's, let me see what is it. Let me see what map. What is this?
Actually, you have a street on the top section of the site,
Ah,
and you can see different families living on the different parts of the street based on the
wow, this
outcome.
is so beautiful.
And you
Oh
can
my.
check the details of their living, like how their beds
Oh,
look
and
like,
it's a
how their,
map.
yeah.
So beautiful. Cool. Yeah, we should check it out later.
Yeah.
Anyways, we give meaning to space and we call that place, right? This is how y'all, each of you have these different understanding of where you live, okay? And you can draw it. This is something, one of the most seminal works on city planning in general was Kevin Lynch's image of the city.
Kevin Lynch. In 1960, a professor at MIT named Kevin Lynch concluded a 5-year study and published the findings in a book called The Image of the City. In it, he examines the way that people mentally map their city and what makes a place coherent and cohesive to its inhabitants. Lynch found that people created mental images of their cities using very similar components. He named these components paths, which are the routes we travel on, nodes, which are major intersection points that force us to make a decision, edges, which are boundaries we use to distinguish between one area and another, districts, which are bigger areas that contain all other elements and evoke a strong central theme, and landmarks. Landmarks are points in the environment around us that help us understand exactly where we are. Think of a distinctive building like the Capitol building in Boston or the Empire State Building in New York, or really any other big building you can think of. If you have a general understanding of where you are, you can use that building to orient yourself. The more familiar you are with the space, though, the less likely you are to use a distant landmark. Instead, you'll find smaller, personalized landmarks like that one awesome mural or that weird green statue that everyone hits their head on. Landmarks help us to contextualize our spaces, to create a more concrete image of the places we live in. The more landmarks available to us, the more readily we can understand the environment around us. Kevin Lynch referred to this as the imageability of a city. But how do you create an image of a city when you can't see? One of the major issues for people who are blind is a lack.
Okay, so the last part is important, but not really the point we're trying to make today. The point that we're trying to make with our exercise is that, like, you already, with these few maps, we pretty much replicated what Kevin Lynch showed. You, in general, humans in general have the ability to abstract the place. They live into these nicely categorized elements, these locations, these paths, these districts, these landmarks, and you, the Costco's are the landmarks for you, right? And then these districts and the edges were the river banks, and so you all did it. And some people had a stronger sense of roots, and some people had a stronger sense of regions and districts. Okay, I find this super interesting because Kevin Lynch's study, where he asked people to draw what they remembered of a city, was pretty much the same as how we in general make maps. So now getting back to the idea of visualization, the way we think of visualizing anything spatial works in the same way, right? So these geographic information systems are these softwares that help us manage, analyze, edit, output, and visualize geographic data, right? And then it's very simple. Geographic data are data that have locations associated with them, okay? So for the very least, what you need are these coordinates: the latitude, or the y, north or the amount north or south of the equator, or the longitude, the x, east or west of a universal vertical line. With these two, you can place something on the earth, okay? But it's also important to know that geographic locations are projections. So who here believes that the earth is flat? Do we have any flat earthers here? Hopefully not. What we believe, at least we know that the earth is a sphere, right? It is here. Yeah, yes. The earth is on a turtle, actually. That I also agree with. But assuming, let's not get into flat earth versus donut or sphere conversations. But assuming the earth is a sphere, our maps are flat, right? So we have to do something to get those flat things into a square of flat map, right? So we project those locations somehow from sphere to flat, and that creates some misperfection. There's a bunch of different projection systems, and people in geography learned them. I had to study them when I was an urban planner, but not here. We in general just know that you might have to deal with these projections when you deal with data that is geographic. But we usually, in our case, use the most used one. What is the most used one? It's the Web Mercator, which is this one specific way they create projections from the sphere to the flat. Google Maps use it. And a lot of the data that you're going to use, if you use geographic data, is using this. But you might find some different weird projections that are local. Again, if you face that problem, we're going to talk about it. Just know this is something that, again, a lot of what I'm teaching you in this course is that, hey, just know that this problem might occur, and then you can ask the right questions. Okay, now that we've thought about it, asking this question again. Now, the first one I showed you this map, I asked you what on this map, right? But now that I've taught you about the things that Kevin Lynch talked about, you can again see those visual elements, right? Those things that those edges and those districts and other things, right? But now in the language of visualization, those marks, those graphical marks are here, right? You have your circle marks and you have your line marks and you have your area encodings and you have these color encodings, right? So it's the same problem. Visualizing map is the same problem. So think about that. So how is the information shown on a map? Very simply, through points, through lines, through polygons, and through pixels. Pixels are images that can be projected on a map. Okay? These are the four main types of geographic elements that we use to put on a map. Now, these points can be represented in different shapes. That would be your marks. But more often than not, you have these four main types of elements that you use. Okay? So how can we visualize Vancouver now, right? That is an important question. Because Vancouver can be represented in different ways. It can be the center of Vancouver. It can be the area of Vancouver. It could be the streets of Vancouver. But we need to find that. We need to know what we mean when we mean Vancouver, when we say Vancouver. And then we need to turn that somehow into geographic information. So there's some level of ambiguity when we do this. Okay? In many cases, we are dealing with location types that are semantic, not yet geographical. We understand the location nature of them, the spatial nature of them, but they are not yet ready to be visualized. So addresses are something that we understand. Zip codes are something that we understand. These are different ways that geography, humans have created geographic representations. Place names, okay? So when you say Vancouver, it's a location name, right? But then you have to decide how that is turned into an X and a Y coordinate. Distances, right? So essentially, we need to infer these locations and then get the coordinates. And this is a process called geocoding, getting these semantic things and turning them into geographic coordinates. Remember, and then there are tools for you to do geocoding. If you needed to do it, we can talk about it. But there are other things that are shown on the map. Attributes, information about these different points, line, polygons, or pixels. And that's why it's called a geographic information system. For example, if we have these map of Vancouver with different locations, that point would be Alireza's house. It's a 6-story building. A color is red and the population is 1. We have data, information associated with this, right? And this could be Seat, 2-story building, population of 150, black. So you can have arbitrary attributes related to these different things on your map. And then this is where your knowledge of visualization and encoding channels and everything comes into play. Then you decide how these elements on a map are visualized. Okay? So just thinking about these, now most of you have you have a lot of visualization knowledge, so you can just get creative. But here's some few examples of how you can think about them. Okay, So you can have a dot visualization, you got a graduated dot visualization, you can have a symbol visualization, you can have an icon, glyph visualization for points. For lines, you can have a network visualization, you can have a flow visualization. We're going to see examples of these. For polygons, you can have a choropleth, and then you can have tiles and other sorts of graduated pixel visualization. So let's see some examples of these. The simple marker dot map is the most prevalent. You all have seen it every day. You click on a place on Google Maps and you see the name. That's a marker visualization. Marker are just to show you where things are. Google Maps, easy to interpret. And then you can use these sort of colors to encode what category that marker is, right? So you can already do interesting things to visualize markers. But the marker itself is only encoding location. You can also do these interesting things like dot density maps to communicate, let's say, population. This is New York City, and it's showing each basically dot is showing the density of a specific race. So the more green dots in an area, that means there's more black people in that area. Or blue. Yes, blue is black and green is white. Okay, so dot density maps are easy to understand relatively, and what they're encoding is the population of region by placing points within them. So essentially, if the larger the population, the more amount of points, the larger amount of points they put in that area. But it's, in general, people underestimate density, and it's hard to accurately calculate these types of things. If dots are too dense, it's difficult to read. And dot placement is critical. If jittered pattern is less meaningful. So again, it's an interesting way to visualize something that's super complex, but you have to be careful when using these types of visualizations. You also have symbol maps, similar to a marker map, but then you're changing the size channel or the color channel to incorporate some attribute about that point. You all have seen this map probably. This is probably the population of different cities, I think, right? So you can encode a value into a visual channel of a symbol. It's basically a scatter plot, but coordinates are on a map. So you've already made scatter plots. This is exactly that. Okay, and we have already seen this example. You can use glyph and interesting things that have semantic information encoded in them. And you can use direction. We've already looked at this, right? So this map is showing all the counties in United States that have shifted more Republican versus the ones that have shifted more Democrat in the last election. So color is used here, direction is used, and size is also used as encoding channels. We have line maps. Line maps are simple. It can help you identify its directions, move around. We're super familiar in how to read them. We can have flow maps. Flow maps give you a sense of flow of things spatially. So here we know that there's more traffic flowing in this part of this line, right? You can read it. Google Maps has popularized this stuff. You can also visualize flow in different ways. You can get creative. There's also these spatial networks. Networks are a specific type of data where you have nodes. These are centers of things, and then you have links between them, and attributes can be associated with them. So you could say, okay, I have these different cities, and then I can have these links between them that show how much movement is between these two cities. These are really useful ways to visualize spatial information, and then you can get really creative in how these data sets are represented. If you're interested in these types of data, let me know. I can share some resources to you. Choropleth map, probably most familiar with it because These are the political maps. Okay, you've all seen this in Canada, in the United States. These are maps where polygons are colored based on different thematic information. So this is which states, which one have been won by Republicans, which one have been won by Democrats, and the ones that are close. So you can do this, right? So color is encoding something, and then you can add different types of colors to encode different types of information. Here, color is used, but it's used with with also some quantitative information, right? So where a polygon here is green, it means the majority race is that race, and then the color also shows the density. So you can communicate some interesting information. You have to parse that information the way you want to do it. You can make these corpus maps with quantitative data. So you can basically, remember how we used to create bins with histograms? You can do the same thing. And then you can just color code each polygon to show the population of an area or anything in that area, any sort of count. So if you're working with census data, this is your jam. You can make a lot of, but you have to be careful because land is not the same thing as people. So let's watch this.
Visual aid that we see over and over again.
Show the Mitt Romney map.
Look at that map.
Let's go back to the 2000 map.
And it is in dire need of a redesign. Just look at this map. It's not just unhelpful, it's actually misleading. It shows the states that Mitt Romney and Barack Obama won in 2012. Without more information, it's really hard to tell that Obama actually won. He beat Romney by more than 100 electoral votes. So while this map does a great job telling you that Romney won Montana, for example, what it doesn't tell you is how much that victory doesn't matter. It's because Montana only gets 3 electoral votes. Massachusetts gets 4 times as many, and you can barely find it on the map. And that's because the people who made this map made a choice. They chose to prioritize geographic accuracy over electoral importance. And geographically accurate maps are great for road trips, but they don't do a very good job telling us how the country voted. So some designers have tried other solutions. They're making different maps called cartograms. These maps distort the state's shape so that their physical size corresponds not with their geographic boundaries, but with the number of electoral votes they get. Here's a version designed by the New York Times, with each state scaled by electoral votes. They've ditched the precise borders of each state in favor of squares, but still arranged them geographically, so it's easy enough to find your own state. Another approach from the Daily Kos makes room to report the popular vote from each congressional district. But so far, these ideas haven't been widely adopted. So does this mean that we're stuck with bad maps for another election cycle? Not necessarily. There are so many different ways to visualize information. Why not show a list of states or a series of bar charts? All of these methods tell you so much more than those ubiquitous red state, blue state maps.
So yeah, even though you might have this inclination to visualize something on a map, and it's really sometimes really important, really cool, sometimes you need to get creative. Also, think about other types of visualizations that would just use the name of a state, or even think about pairing different visualizations together to help you communicate both information, like the important information. So this is a very recurring theme in our course, right? That you have to make a decision when it comes to visualizing data. Okay? Now, lastly, data for map is different formats essentially. So you can obviously use CSVs, and there's a format that's called shapefiles that I hate. It gives me trauma, but you might see it in these city or government websites. And there's GeoJSONs, which is a really nice modern way of representing geographic information. If you had to deal with those, you can Google it. But in general, what I suggest is you try to get these and use some sort of AI or write a Python script and translate them to these. Because the way we are going to visualize data, it's just so much easier to use GeoJSONs. GeoJSONs, you've all seen JSON formats. GeoJSON is a very specific type of creating a JSON file that tells the software, if you tell the software that this is a GeoJSON, that it knows how to read it, it knows where the attributes are, it knows where the locations are. So it has a type, there's geometry that records the geographic information. See there, the type is a point, it has the coordinates, and then all the stuff about that point are recorded under properties. And then these features and the type that you can give it are points, line strings, polygons, multi-point, multi-line string, and multi-polygon. It just means that you can save multiple things into one object. Coordinates are always arrays of coordinates. So if you have like a line, then it will be an array of points that look like this. And then let me geojson.io. All right. So let's just go to ChatGPT. This is where you actually want to use AI. Give me a GeoJSON of Vancouver in polygon format. Come on, I don't answer now. This is easy. Wow. Can we run it again? Oh, okay. Should be good enough. So type is a feature collection. It has features, so let's just paste it here. Boom. It gave me a square. That's fine. Remember, it matters how we represent it, but it's useful because it's giving us these 4 coordinates. The type is a polygon, and then inside of it are these points that are going to represent it. And the properties it's giving us is only the name. Okay, if I just add population to the JSON and then just say 10,000, and then and it should also just show the population of 10,000 for this. Okay, now I'm going to ask it to now give me a more accurate polyline GeoJSON of Vancouver boundary. Let's see what it does. It's also useful because we're going to have an AI session soon, but as you can see, a polyline will be more points. I'm just going to copy that and see what it gives us. This is what AI can do without some supervision, but you can at least see what, just like a ballpark representation. Is it okay if you copy things like that? It's okay if you copy things like that, especially, again, we're going to have an AI session soon, but sometimes when you copy it, the data is bad. So you need to use your own critical thinking in such cases. But sure, if it's totally cool to use AI, in my opinion, for data transformation. For coding, it's fine to use AI as long as you learn how to use it. You need to be able to specifically tell your agents or whatever tool you're using what you need, because if you just give it this question that I just gave it, it'll be bad, it'll be wrong, and then it'll be obvious why it's wrong. Okay, so learn about GeoJSON, because GeoJSON is something that you are going to use. Okay, so as you can see, we drew a rectangle, and then we just practiced making maps by just drawing it. But Tableau can help you make maps. There's a really good software that I highly suggest y'all using if you're making spatial data. It's free, called QGIS. There's a lot of good resources online to make static maps. It's really useful. It's a really good software to make maps that you could share at some of your works. But Leaflet is something that we want to use. Leaflet is very simple. Okay, I have code for you that you can use. I'm gonna quickly just show you how simple Leaflet is and show you an example, and then you can read the code because you're all experts now. Leaflet JS is a library specifically designed to create interactive maps. It's so easy to use. And we're going to see how that is. The tutorial is amazing. This interactive choropleth map teaches you how to make a visualization like this with like populations of different US states. You can basically replicate that for Canada if you want. It's step by step. So again, just if you read this, it gives you most of the things that you need to do. But here, let me just give you a quick sense before we move to project mode. Okay, just like how we use D3 or VegaLite, what you want to have is a div with an ID, and then you can select that ID and put stuff in it. Okay, so I'm gonna just create. Oh, and I've already loaded the library here. So there's the script that is the CSS, and then there is Leaflet loaded somewhere as well. Yeah, Leaflet is loaded here as well. Anyways, you can use it loaded here or in the head. It's better to load it in the head. So essentially, you can create a map variable, and it's the way it works is basically L dot map, and you just give the ID, and then you just set the view. The view is a ballpark area of where you want the map to start, and this is the zoom level. Okay? From this point on, you just add things to that map. So I'm just going to copy the basic tile layer. So you see, I'm saying L, which is leaflet, create a tile layer, and then add that to map. With these few lines of code, we now have a zoomable map that does basically what Google Maps does, right? So this is so good for you. You can create interactive maps this quickly. Okay? What else can we do? Now, let's try to add. I can say, okay, give me the Vancouver boundary, right? And then I'll just copy and paste the data. So see, an array of points, okay? And then you can add that to map. How would you do that? You can create boundary polygon equals L dot polygon, and then pass the data to it. Let's see, and then you can just go add to map. We added that polygon. Okay, and then to make it interactive, so super simply, you can just say bind pop-up city of Vancouver. With that, if you click on it, it shows you the name as well. I'm just going to show you just another example. If I want to create a marker, I can just go const downtown marker equals L dot marker, and then you just put location as a point inside of it, and then you can go add to, boom, it's there. Okay, and then same goes with line. You can add a circle. So I'm just going to copy and paste now, just so you see it's just super easy to use. I just added a circle. Okay, it's the same idea. You can add attributes for that, how you want it to be colored, just as an object. You can add it to map again, and this is it. You can create markers, all sorts of stuff. Okay, so that's like how you manually add the data, but I am just going to show you the code. You can load your GeoJSON data like this, and I'm going to give you the data set. And then Leaflet has a GeoJSON method. Instead of just saying polygon, you can say l.geojson and just pass the GeoJSON to it, give it style, and you can add it to map. And then you can tell it, do something for each of the features. You can just give a lot of different functionalities. So with this code that I'm about to give you, which is basically a kind of more complete version of that tutorial that's there, you can see something like this. You can create something like a choropleth. You click on it, you can zoom on it, it shows information. When you hover, you can see sleep hours. So that code gives you that example of choropleth. And then you can get creative. We have a legend here. Again, there's a lot that you can do. So I have this in GitHub for you. You can see how basic maps are created. You can see how you can use GeoJSON data. A really good workflow is to get your data into GeoJSON format and then just use some flow like this GeoJSON file that I'm giving you to make your visualization. I have a question here. Let me see.
If we use Tableau, is there a way to make it give us a code to add so it's not like a screenshot?
For your final website, I don't want you to use Tableau to create embedded visualization. As long as there is a very specific reason why you're doing that, it's fine to create images. If you use QGIS, I know QGIS has a plugin that gives you a interactive code. However, again, it is really simple. If you wanted to do, if you got to that point where you want to use Tableau to put it in your website or something, you can just use QGIS and do that. I think if your question is just generally, I would just suggest using QGIS to make your map visualizations. Yeah. But again, maybe I think Tableau has like a way to embed its outputs, right? So you will probably have to go that route. I don't like Tableau as a production level visualization. It's really, in my opinion, it's really good to make visualizations in an easy way. Yeah, and quick way. You're right. It's very easy and quick. Yes, it is. But then I think when you've done the exploration as an expert, what you want to do is to just figure out what would be that Vega Lite or D3 code that gets you that production level sort of interactive version. But you should use Tableau to prototype, in my opinion. Okay, I'm done. This was the quickest intro to Leaflet because, again, I don't think you need me to walk you through how to do this. This tutorial is just so good. How I learned how to use it. And then I've already showed you the basics of it. If that's all good, whoever is deciding to do spatial visualizations, you can talk to us and we can also help you troubleshoot or find geographic data and go from there. Do you have any questions? Because we can take a 5-minute break and then get to 5 minutes each for your presenting what you have in your projects. No questions?